Hi guys, today we have two goals. One is to make a box plot when given a 5-number summary, and the other one is to know how to describe a distribution when you're looking at the graph. Okay, so let's get going. To make a box plot when given a 5-number summary, well, the first thing you need to know is what is a 5-number summary? A 5-number summary is a way to summarize a data set, what's going on. Okay, so when we look at a 5-number summary, obviously, there's 5 things we're looking at. What are those 5 things? We are looking at the minimum number, quartile 1, the median number, quartile 3, and the maximum number. Okay, this is a way we can summarize the data set, and it gives us a lot of information. Then from there, what we can do is we can make a box plot, what you maybe have heard of as a box and whisker when you learned this maybe in middle school. Okay. All right. So let's look at this. I have an example of a 5-number summary. I came up with a data set and I found the 5-number summary, and you're going to be given the 5-number summary. You do not need to know how to find the 5-number summary yet. Okay. So how am I going to make a box plot based off of a 5-number summary? Whenever you're making a box plot, what you want to do is you want a nice long number line. You want to look at your minimum and you want to look at your maximum. And the reason you want to do that is that's going to help you know how to scale your number line. So because I'm going from 2 to 20, I could go by 1s, but I prefer to go by 2s. So I have 0, 2, 4, 6, 8, 10, 12, 14, 16, and 18, and finally 20. So do that for me now. Okay, so we have our number line. That's the first thing you want to do. Look at your minimum, look at your maximum. The next thing you want to do is you want to look at this 5-number summary and you want to dot where each one is just above the number line. So we have a minimum of 2. So I'm not going to put the dot on the number line. I'm going to put it just right above the number line. I have quartile 1 of 5, so 5 is approximately right here. 10 is right here. 12 is right here. And 20 is right here. Okay, we have our 5-number summary as 5 dots right above the number line. Okay. The next thing that you want to do is you want to put a line through the median. And you want to put a line through the quartiles. And then you want to connect it like a big rectangle here. That is your box, okay? That is your box. So the box always goes around the quartiles with the median in the center. All right, now we need our whiskers. Now our whiskers go out to the max and out to the min. And there is your box plot when you're given your 5-number summary. That's it. All right, let's move on to now describing a distribution. Whoops. When you are describing a distribution, you're summarizing what's going on, okay? So there is an acronym that we use. Some teachers use different acronyms like SOCS versus SOCS. It's all the same thing. I know some people say CUS. I like SOCS, so that's what I use, okay? So I want you to do right now, write out in your notes, SOCS, okay? And what we're going to do is we're going to say what each one stands for. Okay, so what do they stand for? The first one is shape. The O stands for outliers or anything unusual. C stands for center, and S stands for spread. So that's all right there. Now, when you're describing the distribution, you're going to look at the shape of the distribution. There are 3 different things that could be. The shape of the distribution could be symmetric. It could be skewed to the left or skewed to the right. And I'm going to show you in the next slides what those look like. But for now, just get down in your notes the 3 different things that we usually happens in stats. Symmetric, skewed left, skewed right. Now, there's some other ways we can talk about it too, being like bimodal, so on and so forth. We're not going to worry about that for stats today, okay? We're just talking about symmetric, skewed left, and skewed right. Now, outliers. Outliers, I call this the shack factor. Think about it like this. If I was going to make a dot plot of all of our shoe sizes, okay, right? A lot of us would probably be around here, some down here, some up here for those people who have larger feet. But then if Shaquille O'Neal walked into the room, he'd be like way over here. That is a potential outlier. Now, right in here in this dot plot, you can see this. These are just gaps, okay? But I don't know that I would necessarily call this an outlier. Right now, for an outlier, you need to think, does it have the shack factor way out here all by itself because his feet are enormous, okay? Outliers or anything extreme, also be looking for gaps. Center. The center really is the average or the median, but for now, we're just going to approximate what that is. So when you're looking at the center, what you want to ask yourself is, what is one number that summarizes the group? Can you pick one or like a range of numbers that would summarize the group? Again, I'll show you how to do that on the next slide. Just write it down for notes for now. And then finally, the spread. The spread is describing the variation. Is the data really spread out or is it not? Okay. For now, what we're going to do to find the spread is we're going to find the range. And the range is the maximum number minus the minimum number. Okay, let's practice this together by looking at several graphs. So we're going to describe the distribution of these graphs below. And these box plots, we're just going to look at the shape. So I have my SOCS, and in regular sets, we are okay if you just do the bullet points, okay? So the shape of this distribution, what I like to do is I like to draw just a line right over the tops of the bars or the dots, okay? And I'm going to imagine now if I was going to fold this in half, okay? If I would fold this graph in half, would it match up perfectly or almost perfectly? It doesn't have to be perfect. If it matches up perfectly right when I fold that paper in half, then we call that symmetric. So this is a symmetric distribution. Are there any outliers here? Is there a Shaquille O'Neal factor? No. So what I say is I just go NA, not available. What is the center of the distribution? What is one number that would describe what you think is going on? And right now, again, we're just approximating, okay? So I think that's going to be 2. And then finally, the spread. How spread out is it? And there's other measures for center and spread that we're going to learn later. But for now, again, we're just approximating. The spread then would be the max minus the min. So that's 4 minus 0, so that's equal to 4. Okay, shape, symmetric, outliers, none, center, 2, spread, 4. All right, let's look at this next one. Again, I like to draw my line over what's going on. So if I would fold this graph in half, right? You can imagine if you have this rectangle cut out and you're going to fold it in half, okay? Would it match up perfectly? No. We have a skewed distribution, okay? Skewed distribution. Now, here's the deal. It is skewed, okay? But which way is it skewed? So first of all, why is it skewed? Let me explain again. Imagine if you cut this out as a rectangle and you fold it in half, would it match up? It doesn't match up, so we know that it's skewed. Sorry here. Now, which way is it skewed? What you want to do is you want to look at what side is thinner. What side doesn't have as much data? We don't have as much data over here on the right side. It's the thinner side, okay? Like you can imagine if I was going to color this all in, right? I'm not going to have as much coloring over here on the right side. So what we do then is we say that that is skewed right. Are there any outliers? Is there a Shaquille O'Neal factor? It looks like there is. And let's see, it looks like that's 100,000. So there is an outlier, a potential outlier, I'm going to say, that is greater than 100,000. Okay, that's that Shaquille O'Neal factor here. Okay, he's hanging out outside here. Everyone else is over here with their shoe size, but Shaq is way out here. Okay, now what would be a center that you would say, hey, what's one thing that would kind of approximate what's going on? Well, it's a little harder because it's skewed. We wouldn't say this first bar, but maybe somewhere in these two bars is the center, a good way to describe what's going on. And so it looks like it's going by 10,000s. So there's 40,000. This would be 50,000. So I'm going to say anywhere between 40,000 to 50,000 is the center. Okay, so now that we know that it's going by 10,000s, we know that this is 110,000 right here, okay? And this is going to be 30,000 right there. So I'm going to take 110,000 minus 30,000. And that's going to give us 80,000 for the spread. Again, this is all just approximations here. We're just kind of trying to figure out what is that center? Is this a potential outlier? The biggest thing is that people are sometimes uncomfortable is how is it skewed? And just think, where is there less color if you were coloring this all in on the right-hand side? Okay, now we have a stem plot here. And a stem plot is sometimes difficult for people to describe the shape. So what I like to do with my stem plot is I like to rotate my head, 90 degrees, flip it and look at it like this, okay? And now what I'm going to do is I'm going to just draw again over the tops of the numbers. And you can see here now, if I would fold this rectangle in half, would my numbers match up on this stem and leaf plot? And they wouldn't. So we know we have a skewed distribution. It is not symmetric. Okay, now think about it as the coloring again. If you were going to color, where is there less color? And there would be less color over on this side. Okay, so that means I am skewed left. Okay, so we have decided it is skewed left. Why is it skewed left? Because if you're going to color it in there, there's less color on that left-hand side. Now I'm going to erase so we can look and see, are there any outliers? Is there a Shaquille O'Neal factor? Well, we don't know how to calculate outliers yet, but I don't think these are really outliers, okay? There's not a whole lot of difference between 62 and 45, but we really don't know. So what we could say is we could just say there are potential outliers at 45, and 30 very well could be an outlier as well, okay? Potential outliers. There's for sure a gap right there, okay? And so this would be potential outliers. All right, now the center. What do you think would be one number that would say what's going on with this distribution? And I would think, hey, if I'm going to pick one number, it would be anywhere from 80 to 90, okay? Somewhere in this area, okay? So I'm going to say 80 to 90. And again, you're just approximating, and I can help you with that if you need to, okay? And then finally, the spread. I'm going to take the range. So this is my stem of 10, and then I have a 0, so 100 minus 30, which is going to give me 70. Okay, now what I have is I have 3 box plots here, and sometimes people have a hard time deciding the shape of a box plot. It's similar to the folding in half, but now what you're going to do is you're going to fold on the median line. If I was going to cut this out and fold right where this line is, would it match up almost perfectly? It would. So we're going to call it symmetric. Now remember, in stats, it doesn't have to be perfectly matched up, but if it's close enough, we still call it symmetric. Here, I'm going to again imagine cutting this out. Folding on this line. Is one side going to be longer than the other? I think that this side over here is going to be a little longer. Not a lot, but a little bit. And that's why I'm going to say that that is skewed. Now, which way is it going to be skewed? It's a little longer, okay, this on this side. So that's why I'm going to say this is skewed to the left because it's on the left of the median. This side looks a little bit longer, not a lot, but a little bit, especially from the median to that quartile 3 is longer than the median. I'm sorry, the median to the quartile 1 is longer than the median to the quartile 3. Okay, that's another way we can look at it. So we're calling that skewed left, okay, right? Because even if you look from the median to the min and the median to the max, it could be similar lengths, right? But what really gives it away is if we look at the median to quartile 3 versus the median, I keep saying quartile 3, sorry, the median to quartile 1 versus the median to quartile 3. That green line is longer, which really that gives it away that we are skewed left. So that's another way to look at it. And then finally over here, again, if I was going to fold in half on this line, right? This side is going to be longer. It doesn't match up perfectly. That's how we know it is not symmetric. It is skewed. And the longer side is on the right-hand side, so skewed right. All right, perfect. Let's go on to the last slide. The last thing we're going to ask you to do is to compare distributions. And when we compare distributions, we want to use SOC and S again. And we want to use comparison words when appropriate, okay? So, for example here, the shapes of the distribution, well, let's read the context first. Below is a histogram of high school students' hours watching TV from July 1st through 15th, and then again from October 1st to the October 15th. Compare the distributions. So let's look at now the shape. Okay. The shape here, it's slightly skewed right. The shape here is also somewhat skewed right. Not a whole lot, but a little bit. There is a little bit of a thinner side over here. If you're going to fold this square in half, it would not match up perfectly. This one might match up a little bit better, okay? But again, still not perfectly, okay? So we have both distributions are slightly skewed right. Well, next, outliers. Do we have any outliers? Well, it looks like from July 1st through 15th, there could be maybe an outlier here. There's at least a gap or an extreme observation. Let's look at the time there, anywhere from 120 to 127. So we need to write that down. Is a potential outlier from 120 to 127. But it looks like in October, there is no outliers. Okay, the center now. See, if there's one number to describe what's going on, what would we do? What would we say? Well, look what they gave us. They gave us the mean and the median here, and the mean and the median here. And it looks like the centers for July are greater, right, than the centers for October, okay? So we want to use comparison words. The center for July is greater than the center for October. Again, you don't know how to find the mean and the median yet. We're going to teach you that. Well, you may know, but we're not expecting you to find that yet. But what's nice about this distribution is they gave us that right up here. And we know that the average or the median is a way we can describe the center. It's a summary of what's going on in general for that distribution. And again, those summary statistics here are greater for July than they are for October. Now, finally, the spread. We know that the spread is the max minus the min. And they actually gave us that here, 75, right, minus 2. So the range here, right, guys, the range is 73. Here we have 129 minus 4, right? 129 minus 4, that would give us a range of 125. The spread for July then is greater than the spread for October. So we're going to write that down. Okay, so what should you have learned here, guys? When we are comparing distributions, we need S, O, C, and S. Okay? When we're looking at it, we can say, when we fold that histogram in half, doesn't match up. It's not perfect, okay? There's a little bit more of a thin side over here, again, over here. And I'm going to teach you, I'm going to give you some more information for how we can tell if it's skewed versus symmetric. If you're questioning it at all, we can look at the mean versus the median. We're not going to do that yet. We're not there yet. Okay, so now you're making your best approximation. The same thing for an outlier. We're going to teach you how to calculate if it's for sure an outlier or not. So now we're just speculating. This is a potential outlier over here. The centers, again, you're approximating. The nice thing is the center is giving us one number or a little range of numbers that's describing or summarizing what's going on for the whole data set. And in reality, that is the median and the mean. Those are measures of center. You're not expected to calculate that yet. Okay, you're not expected to calculate that, but you are expected to approximate that. And then when it's given to you, well, that's really nice. We can easily see, right, that the measures of center there are greater in July than October. And then finally, there are measures of spread such as the IQR and the standard deviation. We don't know how to calculate that yet, but we can easily calculate the range. And that is a measure of spread as well, and see that it's greater here from July versus October. All right, guys, good job today. We will see you back in class. Make sure you're pausing, writing down notes, just a reminder as you're watching, rewinding any part that you might need for better clarification. Have a great day.